We remember that we can use the activator class for creating instances through reflection. Let's try creating a list of person. We call create instance on the activator passing through the type, a list of person. And then we write out that type. Let's give that a try. And indeed, that works. But this isn't really special, nor is it very useful. I could have just newed up that list of person, right? This gets more useful once we consider the fact that the generic type itself is something we could separate out. In other words, if we know we have a certain generic type, and we know the type of the type argument, then how do we create that through reflection? Let's add a new generic class to work with. Let's say result of t. The actual value is of type t. We're going to ignore the null reference warnings, that's not what this demo is about. Constructs like this are typically wrappers around a certain instance to allow passing through additional information next to the actual value. A result of t could contain remarks on the value instance, or maybe a list of errors in case the value wasn't successfully fetched. That's what the remarks field can hold. Alright, now let's try and create a result of type person. First things first, we want to pass through the generic type itself. That's the result of t class. We can't just pass through result t as t hasn't been specified. But as we learned, we can use an open type for that. And let's write out that type to the console output window. Let's give this a try. Well, that's not good. It fails. Apparently, there's an argument exception. We cannot create an instance of reflectionSample.result of t because type.contains generic parameters is true. This is actually telling us that we need to pass through the generic argument type. That is type of person in our case. But how do we do this then? Well, we can explicitly state that we want to make a closed type of our open result type by calling into make generic type on the open type. So we first get our open type, then we state we want to make a closed type of it, and to that make generic type method, we pass through a parameter list of types. Those are the types of the generic type arguments. In our case, that's type of person. In case you have multiple types, like a dictionary of TS, you can just keep on passing those types through to make generic type. The return type from make generic type is the generic type. So we can now use create instance on our activator to create an instance of that closed result type. And now let's write out the result. There we go. Let's give this a try. And that's a lot better. This works as expected. Now imagine that all we have to go by is the name of the types as strings. We remember that we can create types from a string through type.getType. Important here is how to represent the generic type as a string. From the previous demo, we know we have to state the amount of generic type parameters to be CLS compliant. So we pass that through together with the name of the type. That gets us our open result type. To make generic type, we then have to pass through the person type. And there's nothing new about that. We already know how to get the type of the person. Then we create an instance of it again, and we write out the result to the console output window, so we can have a look at what this results in. And let's give that a try. And there we go. This still works. As far as constructors are concerned, there's nothing new. We learned how to do that in the previous module, and it works exactly the same as for non-generic types. What is a little bit different is invoking methods, or rather generic methods. Let's check that out next.